I think you must have seen this before, because this is something that is often seen in airplanes. This is called reverse thrust. Why there is something like this in airplanes? What does this do? I invite you to stay with this video to know all this. Reverse thrust is the process of directing backward thrust forward. Usually, reverse thrust is not as strong as forward thrust. There are reasons for this. A plane is designed to go forward quickly. Then the engine of the plane is designed to provide very good forward thrust. But a plane does not need to go backward quickly. Therefore, the engine of the plane is not designed to give a lot of reverse thrust. This is why reverse thrust is not very strong. There are several main purposes of implementing reverse thrust like this. Let's talk about them now. To reduce the speed of the plane. Here, after a plane has landed and touched down on the runway, reverse thrust is used to reduce the speed quickly. How does a plane usually move forward quickly? When a jet engine directs air backward, the plane moves forward. To be precise, according to Newton's third law. So the same thing happens in reverse thrust. By sending a fast airstream forward and applying force to the back, the plane slows down. But remember, reverse thrust is not the only way to slow down the plane. In addition, there are many other ways. For example, you can show the brakes, flaps, and spoilers on the landing gear. Then reverse thrust only slows down the speed of the plane. Also, this reverse thrust is very useful when landing a plane on short flights, because then the plane can be stopped quickly in a very short distance. Another thing is that reverse thrust is also very helpful in landing the plane during the rain, because during the rain, the plane slides a lot. Then the brakes of the landing gear do not work properly, because the wheels slip. At such times, reverse thrust is definitely needed to stop the plane. Similarly, if you need to stop the plane from taking off suddenly, then at that time you can also use reverse thrust to stop the plane quickly. Similarly, cargo planes are planes that carry a very large load. Such planes need a large runway to land. So at such times, reverse thrust is needed to stop the plane quickly in a very short distance. The other thing is to prevent brake overheating. Sometimes reverse thrust is applied to reduce stress on the wheel brakes on long runways. Otherwise, the wheels can quickly overheat and damage the tires. I have made a video on how such tires can be damaged. If you want to know more about it, watch that video too. So, reverse thrust is used to reduce the speed of the plane in this way without damaging the wheels. Similarly, in cases where there is no pushback truck or at airports without one, reverse thrust is used to take the plane backwards. But that is a bit risky, because the large air current emitted by the reverse thrust can damage buildings, people, and goods around it. So let's see how this thrust works. First step, air inlet. The air inlet is the first and most important part that provides the right amount of air, the right speed, and the right direction to the jet engine. The high-speed air coming in is reduced in velocity, and the static pressure is increased before it goes to the compressor, because the compressor does not accept high-speed air. The compressor face provides a smooth airflow with no turbulence, even pressure distribution. Second step, compressor. The air coming from the air inlet is compressed to a very high pressure here, because high-pressure air is essential for fuel to burn. Third step, combustion chamber. This part mixes fuel with the high-pressure air coming from the compressor and performs continuous combustion. Fourth step, turbine. The system that extracts mechanical energy from the high-temperature, high-energy gas coming from the combustion chamber and uses it to turn the compressor plus fan. Without a turbine, the compressor will not run. Step 5, exhaust nozzle. The exhaust nozzle is the last part of the jet engine. The gas energy left after the turbine is converted into jet velocity and thrust is generated here. So here is how a jet engine works. Next, let's see how many types of reverse thrust there are. There are 3 types of reverse thrust. Let's see what they are. Number 1, Cascade reverse thrust. Cascade reverse thrust is a common jet engine system that redirects airflow forward to help slow an aircraft after landing, using a sliding outer cowl to expose cascade vanes and blocker doors that turn the bypass air outward and forward, providing powerful braking assistance, especially on slippery runways, without overstressing brakes. Why is it called Cascade? Air is bent, the air flows through a series of belts. The steel belts look like a cascade. Let's see how this Cascade reverse thrust works. After the aircraft touches down on the runway, the throttle levers are moved to the reverse position. Next, the translating sleeve on the engine slides backward on the engine fan case. With this, the Cascade vanes are exposed and the blocker doors are closed. Finally, when the translating sleeve moves backward, the blocker doors inside the fan duct close the normal airflow path and block the bypass air from flowing forward. Finally, since the cold bypass air coming from the fan cannot go through the normal exit, the airflow is diverted forward and sideways through the Cascade vanes. Therefore, according to Newton's third law, the aircraft gets a drag force backwards, and therefore the speed decreases quickly. This Cascade reverse thrust has many advantages. Reduces the load on the wheel brakes, reduces the runway distance, increases safety on wet/slippery runways, and improves engine efficiency. This type can be seen in aircraft like the Airbus A380, Boeing 747. Number 2, clamshell reverse thrust. The process here is very similar to what happens in the Cascade. After landing, the throttle levers are put in the reverse position. Then the thrust reverser system is activated. With that, the bucket doors are closed and 2 or 4 pneumatic actuators pivot the doors and close the exhaust nozzle. Therefore, the exhaust gas direct exit is blocked. Then the hot exhaust gas hits the inner surface of the bucket doors and is redirected forward and to the side. Finally, according to Newton's third law, the aircraft gets a reverse thrust force. This type of reverse thrust can be seen in aircraft like the Airbus A330. Number 3, bucket reverse thrust. Here there are 2 bucket like doors behind the exhaust nozzle of the engine. When the pilot activates reverse thrust during landing, the doors are closed and the jet exhaust is directed forward. Then the aircraft gets a force opposing the forward thrust. This method can be seen in quite old aircraft. In addition, propeller aircraft do not reverse the exhaust like in jet aircraft. In propeller aircraft, the pitch of the blades is made negative and the air is pushed forward. Then the speed of the plane decreases. So I hope you have learned something new from this video. If you like this video, like it and subscribe. So see you soon with a new video like this.